bougie, ratchet.
Static is actually the application of mathematics and basic physics in Newton's law to study force in material, machine structure. Static is used to calculate force in systems that don't move or move at constant velocity. Or it means it's concerned with bodies at rest or force in equilibrium. So its foundation course in engineering and strong indicator of a student's future success. There are a lot of static structure in the world, but as a Malaysian, we like to choose local static structure, which KUALA TERENGGANU DRAWBRIDGE. Let's go! This is KUALA TERENGGANU DRAWBRIDGE, and now we want to find the reaction force here. And the first step is FBD. Let's go!
Disclaimer. Some of the dimensions and force acting on the bridge is based on our assumptions.
So this is the FBD. So we have to find the reaction force Bx, By, Ax, Ay. So the distance is 100 meter. From here to here is 75.19 meter. From here to here is 212.67 meter. From this is 2.5 meter. So the force on the bridge is 50 kilonewton. To lift up the bridge is 20 kilonewton. The degree here is 45 degree. The distance from here to here is 106.335 meter.
At point A and point B, it is similar like pin supports. So that's why there is two component of reaction force, component X and component Y on both of them. And now I'm going to explain about rigid body equilibrium and find all of the reaction force from our FBD. This is our FBD. All we need to find is reaction force of A and reaction force of B. But in order to find the reaction force, we need to separate AC, CD and CB. I started with CD beam first, and by using the equation Fy summation Fy equal to 0, we can get C3y. Then we use summation of Fx equal to 0 equation, we can get C3x reaction force. And now we proceed to the AC beam. We can get C1y reaction force by using summation of moment A equal to 0. Then we use summation of Fy equal to 0 to find AY reaction force. Before proceed to the CB beam, we need to calculate C2y reaction force first by C1y minus with C3y. Then now we can find By reaction force by using summation of Fy equal to 0 equation. So we back to our FBD, but now we have AY reaction force and By reaction force. Now all that's left is AX and BX reaction force. Using summation of moment A equal to 0 on our FBD, we can have BX reaction force. But at the beginning we get a negative value, so that means it is opposite to our assumptions, which is to the left side. And for the last calculation, we use summation of Fx equal to 0 equation to get AX. So that's all for the rigid body equilibrium calculations. So now we can proceed to the centroid calculation.
Hello guys, you're with me. I'm gonna show you how to find centroid of a bridge. This is the picture of the overall calculation on finding the centroid of a bridge. What we need to do is to break the shape into simple segments. We will get the two different segments, small and big rectangle. Let's look to the small rectangle. So we should find area, y bar and x bar. So the area just multiply width and the length. For the Y bar, we just add 100, which is the height just now, and 1 meter, which is from the width of the small rectangle, which is 2. We want half of it, we will get 1 meter. X bar, we want the half of the length of the small rectangle, we will get 106.325 meter. And for the big one, 150 for the height and 5 meter for the width, we will get 750. And the X bar, add on the length of the small rectangle, we need the half of the width of big rectangle, we will get the X bar is 215 and 17 meter. Half of the width of the big rectangle is 2.5 meter. And for the Y bar, 150 divided by 2, we will get 75 meter. To find the centroid, we should use the formula given. Y bar equal to sum of the Y bar multiplied by area over sum of area, and same as the X bar. So for the Y bar, we will get the answer is 84.409 meter. The X bar is 175.78 meter. And we move back to the first picture. As you can see there, the marking for the centroid, whereas two lines perpendicular to each other, it shows for the X bar and the Y bar. That's the centroid of a bridge.
That's all from us. Thank you.